All right, this is a review of section 6-5, adding and subtracting fractions. I wanted to start with a problem where the denominators are only numbers, no variables. So let's start with this problem. 2x over 5 minus x plus 4 over 4 plus 2 minus x over 10. The first thing you have to do is figure out what common denominator you want to rewrite the fractions with. You can use any common denominator, but if you use the least common denominator, it will make it easier because all your numbers are smaller. The way you find the least common denominator is you factor all the denominators, and then you keep the highest power of every factor that appears. Because these denominators are just numbers, I'm just going to do the prime factorization of the numbers. So 5 is already prime, 4 is 2 squared, 10 is 2 times 5. So I'm going to write down every factor. 2 and 5 are both factors. 2 squared appears, so I'm going to keep 2 squared, and 5 to the first and 5 to the first are the same. So my LCD is the product of 2 squared times 5, which is 20. So that's the first thing you want to do, figure out what common denominator you want to use. The second step is to rewrite each fraction with the common denominator that you decided you wanted to use. So rewrite each fraction with the least common denominator. This is a step that a lot of you, I think, are trying to do mentally, and it's very helpful to write down on paper exactly what you're doing to change each fraction. So if I'm trying to get each denominator to be 20, my first fraction has to get multiplied by 4 over 4. Remember, you can't just change the denominator, you have to change the numerator too. My middle fraction has to get multiplied by 5 over 5, and my third fraction has to get multiplied by 2 over 2. So one step in rewriting each fraction is to multiply by whatever you need to. And now we're going to actually do the multiplication. So 4 times 2x is 8x. I'm not going to worry about the minus sign. For now, I'm just going to worry about distributing the 5. So 5x plus 20 over 20, and 2 times the quantity 2 minus x is 4 minus 2x. Once you've rewritten each fraction with the common denominator that you want, now you want to do all the addition and subtraction. The goal of rewriting each fraction with a common denominator is so that you can write the expression as one single fraction. So that's why after every denominator has been changed to the same thing, we just combine all the numerators together into a single fraction. So remember, when you are subtracting a fraction, it means you have to subtract all the terms in the numerator. So I'm going to distribute the negative. And now I'm just going to work to combine like terms. I can combine my x terms, and I have 3 of them, and I can combine my numbers. I have 2 of them. So 8x minus 5x minus 2x, I'm left with just 1x. Minus 20 plus 4, I'm left with minus 16 divided by 20. After you do all the adding and subtracting and combining of like terms, the very last step you want to do is to see if you can simplify your fraction anymore. We went from 3 fractions to a single fraction, and now I want to make sure my single fraction can't be further reduced. So how do you know if an algebraic fraction can be further simplified? You factor, and you reduce common factors if you can. My numerator can't be factored anymore. 16 and 20 are terms, and remember, terms don't reduce, factors reduce. So I cannot reduce the 16 and the 20. X minus 16 over 20 is as simplified as I can write that fraction. All right, now I want to do an example where the denominator has a variable in it. So I'm going to do this problem. 2x divided by the quantity x cubed minus 5x squared plus 2 divided by the quantity x squared plus 5x. All the steps that we just used to simplify the other sum and difference still apply, only now our denominators are a little trickier to work with. I still have to figure out what common denominator I want first, and the way I'm going to do that is still by factoring. Many of you at this step are simply multiplying the two denominators together. You get a gigantic denominator, you have no idea how to simplify it. Always start by factoring first. I can take an x squared out of the first denominator. I can take an x out of the second denominator. So the LCD that I want is x squared times the quantity x minus 5 times the quantity x plus 5. Notice that both denominators contain an x, but I kept the higher exponent. One denominator contained the x minus 5, the other contained the x plus 5, and I have to keep both factors. Now I have to rewrite each fraction so that it has the common denominator that I want. It's much easier to figure out what your fraction is missing if you leave the denominator in factored form. So I'm just sort of rewriting what I had on the other slide. Just like I told you when we were doing the example with numbers, write down the transformation. Write down what you have to multiply each fraction by to get the LCD. So this is what we want in our denominator. The first fraction is just missing the x plus 5. The second denominator is missing an x and an x minus 5. So now I've rewritten each fraction, just like in the other problem. Now I have to do all the multiplying. So my first numerator, I'm going to distribute the 2x. 2x squared plus 10x, and that now is written over my LCD. The second fraction, I have to multiply 2 times x times the quantity x plus 5. So 2x squared minus 10x. And all of that is also over the LCD of x squared plus times x plus 5 times x minus 5. Those two fractions are being added. Now that I have a common denominator, remember the whole reason for writing these fractions differently is so that I can combine them into a single fraction. All I'm going to do now is add up all the like terms in my numerator. 2x squared plus 2x squared is 4x squared, plus 10x minus 10x, they cancel out. I've rewritten my sum as a single fraction, and now the last step is asking, can you simplify the fraction that you have anymore? Remember, we simplify by factoring and reducing common factors. Well, my denominator already is factored, my numerator is factored, and I do have a common factor. There is a common x squared that can be reduced from the numerator and denominator. And you're left with a simplified fraction of 4 divided by x minus 5 times the quantity x plus 5. All right, that's all I have to say about this.